Hi everyone, welcome to this video. One of the questions that I get quite regularly is how should an ML ops or ML engineering architecture within any organization look like? Because there are various architectures that are out there. Each software vendor has their own way of explaining how a ML architecture should look like. There are blogs out there, great companies like Netflix, Uber, but most of them try to capture things which are more relevant for bigger organizations and might not be suitable for organizations who are just starting off on their ML journey. So in this video, what we will try and do is we'll try and come up with an architecture which actually works with most of the organizations and it's pretty easy to understand and deploy. So with that, let's start. Alrighty, the first thing that we need to understand is a machine learning architecture or ML ops architecture within an organization is actually a system which connects different parts of an organization to make it better suitable for making decisions using machine learning. Alrighty. Now to understand, one thing is all of this machine learning is most of the cases, if we are not talking about, let's say, generative AI, is something that's post customers interaction with an organization's product or services, right? So if you see on the left hand side in here, essentially is what I'm mentioning here is it's probably somewhere a customer interacts with a production data source, which might be a recommendation for an e-commerce company, which might be a credit system for a bank, and so on and so forth, which I call production data source through a web portal, mobile portal, when they're accessing it through either a mobile phone or a website. So this itself is where the actual interaction actually happens of a customer with business, right? And which we are calling as production data source. Now, machine learning is something that actually uses these production data sources and tries to build a sub product or sub decisioning engine, which allows us to develop better abilities to make decisions, make better products, and give great experiences to our customers. Alrighty, now getting into the overall pipeline. Now, although this system might look a bit complicated, but we can really simplify it by understanding or splitting it into three different parts. First thing to understand is a production data source is rarely used for any decisioning purpose, right? You actually use it, you filter it, you clean it up, and you push it in a place where data scientists and machine learning modelers can actually leverage it to build their models. Post that machine learning model needs to be deployed depending upon different use cases. Whether your use case is somewhere, it's a batch use case where you only update a particular case every month, every week, or every day, or every 4 hours, or maybe it's a real-time use case, a real-time recommendation system, or a real-time fraud decisioning engine. So to understand, so if you kind of abstract it away, that there are things that needs to be done with the data. You take the data and you experiment with it to develop a machine learning model, and third, you deploy it. So in essence, you need three parts of a pipeline. One is called a data pipeline. One you can call a machine learning lab, where actually the model development happens. And third part is where actually this model is taken and deployed in a safe and secure way, so that we see good decisioning and while mitigating all the risks. Cool. So this should give you a high level abstraction of how to think of any ML ops platform or any ML engineering platform. And along with this, there are like multiple things that are subsystems of this, which make this a much better system to run. And we'll get into it as we move forward. Alrighty, let's zoom into the data pipeline. Data pipeline, as I mentioned, is nothing but a system to take the production data source or the data source with the customers or end users interact, and converting into a form which is easily usable for different machine learning or insight generation purposes. So what I've mentioned here is actually a form which has been made popular by Databricks, where you actually take the production data source and convert it into three different stratas right here. You don't convert it, don't do the traditional ETL, but convert it into a direct data dump. You take the data, just push it into place where it can be leveraged. Second is where you take it and clean some of it and make some formatting. And third is gold, which we called as you have made it absolutely readily accessible for the end users for machine learning. Now, the reason for doing this is bronze, silver, gold is it allows the teams to be extremely flexible. If you think of it, when you move to the gold standard, the disadvantage of the gold standard is data becomes extremely fixed. Like if you suppose you have a variable which is like transactions runs in last 30 minutes, you have just made that variable, right? And if suppose someone needs transaction done in last 27 minutes, they have to kind of again go back, make a request to a production data source and kind of come up with a new variable. But having a bronze, silver, and gold where you have data stored in three different formats or three different, I will not say quality is a good word, but three different formats allow the machine learning team to be really flexible. So the data team, instead of being just serving different experiments within the machine learning, actually creates a platform and gives the machine learning team a direct access to all the three platforms. So the machine learning team can go and access the data whatever they want. Ideally, they will be accessing from gold, but if there are cases where they need to really create strong feature engineering, they might go and access something from the silver, or if they want to directly look at the source data, they will probably go and look at the bronze. Cool. There are different tools that are used for doing this. Most of the tools that are used here are heavily SQL based essentially, but majorly people use Apache Spark, Apache Airflow. Data gets stored either in SQL database or non-SQL database. And post that, one of the things that becomes extremely important is data monitoring, right? Data quality monitoring. Like how do you know that the data that's in gold is actually a good representation of what is in production? So this is a service that's actually built and is hugely beneficial to any organization. That how good is the quality of data, like in terms of how timely the data arrives from production data sources. Is it stale? Is it a good reflection of production data source? So data monitoring service, there are various tools that are used around it. There are the tools like Great Expectation, which have kind of become really popular. Then there are in terms of the dashboarding and visualization, people use tools like Grafana and Prometheus to have a dashboard so that everyone looks at the data quality quite regularly. But yeah, that's about it. That's the data pipeline for you, which takes the data and it's not a traditional ETL, but it converts it into forms which becomes much more readily usable when person or when machine learning team wants to develop machine learning models. Alrighty. So the second part of pipeline, what I call is the data and machine learning lab, is where the data that's being created in the data platform or data pipeline can be leveraged to build AI and machine learning models. Now, this is essentially what I call is a lab or something that enables great and faster experimentation. So it can be used for various parts of a machine learning journey, whether it's insight generation, feature selection, feature engineering, ML development. And it has in itself, it has a model validation feature toolset where it allows everyone to have different factors through which they can validate the model. One of the things that this experimentation platform should enable everyone is to faster experimentation, faster validation, due to which you will need lots of either the repos or lots of opinionated code snippets, which can be readily used by anyone who is part of the lab. So think of it as a lab which will have access to all the tools, all the frameworks, all the past knowledge of the teams, which can be leveraged for any future faster experimentation. So that's about it. It's a simple experimentation lab which has connection with the data lab. Now, before we move into the deployment pipeline, one thing to understand it is so far in the machine learning lab, we have built the model. We have built the model using a specific part of the data. Now, in the next stage, we'll look at how do we successfully, in a safe way, deploy this model into production. Cool. Okay, let's look at it. Alrighty, so let's look at the final part of our MLops platform. Now we have taken the data, converted into a form which can be used by machine learning models. We have developed a good machine learning model using past snippets, past knowledge, past libraries. Now we need to deploy it at scale. Now, the first thing that comes in here is the part which we call as unit tests. We need a good unit test library and ability to make data scientists build faster unit tests. This is where lots of generative AI tools have come up, which based on what model you are developing, gives good prompts to data scientists to write unit tests. A unit test allows us to have a safe movement of machine learning models from the machine learning lab to the deployment pipeline. Once we have the unit test, the deployment happens in a very staged environment way, so that we are able to do it in a very safe way. We don't uh, spoil the existing ML workflows. So there are three environments that exist: test environment, pre-prod environment, and prod environment. A test environment is where model is initially moved along with uh, lots of different configuration, and then lots of testing happens on top of it. People test for things like whether it's able to handle edge cases, whether it's able to handle performance things, and so on and so forth. At the top, if you see, there is a feature store. Feature store in essence is a are all the variables or the features that are being leveraged for all the machine learning models within an organization. It has a direct connection with the data pipeline, and it allows us to quickly come up with different features that a machine learning model might need for different ML models. For example, if they're in the gold part of the data platform, there are some features, and we kind of, let's say, create a feature using those features can be coded and stored in the feature store, so that it's accessible by the machine learning models as well as for different other subsystems like monitoring and experimentation and so on and so forth. Now, post the test environment, once everything looks good, it's moved into a pre-prod environment, which is a almost a replication of the production environment. And this is where we start doing integration tests of the model with different other architecture components of the organization, whether it might be front end, back end, other subsystems, and so on and so forth. Post that, once we have the integration test, performance tests, and unit test all says okay, we get approval from different stakeholders, we move the model into production mode. In production mode is where the model actually starts impacting end services and end customers. Now, even here, there are kind of couple of subsystems also that we should know about. First, experimentation management. Lots of organization, in fact, I recommend every organization to do it in a very staged way. But lots of people want to do it as A/B test, as experimentation management. So we need a subsystem to manage the experimentation. Suppose you have a model, and if you are bringing another version of the model in production, how do you make sure that actually is gives you benefit in production? So you want to actually deploy it in a very staged way. Let's say first give it to only 20% of the traffic to the new model, then 30, then 40, and see the advantages. And again, there are different patterns around it, but you need to build an experimentation management service. There are lots of software already available. You can leverage them or build your own. But yeah, I would suggest start with an existing experimentation management software and then go for a something that we want to build in-house. And finally, ML monitoring as a service. Another service that needs to be built, and I suggest it to be built even before you have a proper great deployment pipeline, is monitoring the ML models in production. It checks model for things like concept drift, data quality issues, and so on and so forth. And post that, there are like things like alerting the ML production team, data science team to update the model, check the model, or maybe switch the model to an older version. So in itself, this deployment pipeline is not just something that deploys a model, but also monitors the model when it's in production for any failures or catastrophic problems. With that, I think that's about it. How the MLops pipeline for any great organization or any organization can look like. Now, depending upon the size of the organization, you might not want to go for all of these things that exist within the organization. That is the reason I mentioned some of the tools. Let's say Databricks in itself has its own way of doing a deployment. Google Cloud has its own way of doing it. But one thing that I will suggest everyone is just keep this thing at a higher level in your mind, right? That you need to have levers around the data pipeline, around how experimentation happens, how deployment happens. You can start off with something really simple. You don't need a bronze, silver, and gold. If you are an organization who is just starting off on the ML journey, you just start off with getting the production data source, converting into a form, which is a non-production source, then having another uh, platform on which model development is happening, and post data deployment where you just might have two ecosystems. Maybe you might have just a pre-prod and prod. So start smaller and then go for the deployment. But few things that are non-negotiable is you always probably will need ML monitoring as a service. You will always need data monitoring as a service. So I will say, if you want to, let's say, cut short on stuff, cut short on how different environments exist, or probably on the overall ability of these, but don't cut short or cut corners on monitoring. Start off with building good monitoring system based on your business requirement, based on what are your expectation out of ML model, and then go back and build the complete system. So I think that's about it. That's what I wanted to cover. So if there are anything that I have not covered, and if you might be interested in, please mention them in the comments, and I'll try and make another video probably addressing those questions. Thank you. Bye.